Hi, my name is Philip. Today I will explain to you the KNN algorithm for classification. KNN means the K nearest neighbors. Okay, so let's have a look at this together. So KNN, it is used for classification. When you have some data and you want to classify, to decide what it is. For example, you have some animal, you want to decide is it a cat or a dog. So in general, there are many models to do the classification. It could be the neural networks, the decision trees, and so on. Okay, but many of these types of models, like neural networks, you need to train them. Okay, so before you can do prediction with a neural network, you need to build a neural network with some training data. Then you can use it to do prediction. The same for the decision trees. But training can be very time consuming. If you have, for example, the deep learning neural networks, sometimes you need a lot of data, and it can take many hours or days to train the network. And also, if the data change, training may have to be done again to update the model. Okay, so this is one issue with many classification techniques, and some models will also be huge. So today I will talk to you about the K nearest neighbors, we call KNN. KNN is a lazy approach for classification because it does not require to build a model. So if you want to use KNN, you don't need to train anything, okay? You can use directly to do prediction. So this saves a lot of time for the training. There's no training. KNN directly use the training data to make the prediction. It can be quite accurate. Maybe it will not be the best always, but it is also easy to implement, to do the programming. So how does it work? Okay, let's have a look at this first with some example. Here we suppose that we have some training data. So here I put some pictures of animals. This is my training data in my example. Each animal, we have some information about them, some attributes like the color is gray, the color is white, yellow, and so on. And also we have a class label. This is a duck. Okay, we know the answer. This is a duck. This is a duck. This is a pigeon. And this is a rooster. Okay. Now, let's say we have a new animal we find. Okay. We want to do the classification using KNN. So we know some attributes of this. It is yellow and so on. But we don't know what is the class, what type of animal it is. So the basic idea for KNN, we try to find what looks the most similar to our object, our instance. So if it looks like a duck, it is a duck. Or if it looks like a rooster, it is a rooster. So this is the basic idea. We try to find the most similar animal to do the classification. So to do KNN, we need to select a value for a parameter k. K is the number of neighbors we want to consider. Okay, you will see what I mean. So let's say we choose k equal 3. What will happen? Okay. So we need to calculate the distance between the instance we want to classify the duck here and all the other instances. Okay. So let's say we calculate the distance between this and this. Are they similar or not? We use some measures for distance, and let's say we get 3. Okay, I will tell you how to calculate later. Now this one and this one, they are quite similar, so maybe the distance is smaller, 1.2. Then this one 3.5, this one 4, and the other one 6, because they are very different. Okay. So now we set k equal 3. We want to find the 3 objects that are the most similar, the 3 instances in the training data. So if we set k equal 3, as I said, we want to find the k equal 3 most similar training object or instances. So here, the 3 most similar is the pigeon, the duck, and the duck, because the value 3, 1.2, 3.5 are the smallest among all the values here. Again, I did not say how to calculate the values, okay? Here we just suppose we have a distance function. I will show you more details after. So then what we should do, we keep the 3 most similar objects and we do a vote. We take the majority. So if the majority of them are duck, then we decide this object, our prediction, it is also a duck. Okay. So this is really the basic idea how KNN works. Now let me give you more details, give more explanation. Okay. So the KNN algorithm, if you want to see the idea, how it works, the more details, okay, the input is a set of objects that are described using d dimensions or attribute. So here we have someone 18 years old from Shanghai, is an employee and will cheat. Another person 22 years old from Beijing, employee who don't cheat. And then we have some new object we want to classify. We don't know he will cheat or not. Then the output will be a class. The person is cheating or not cheating. Okay, so this is the input and output. Now let's see the procedure more formally. Okay, so KNN, let's say we have the training data D and we have K, the number of neighbors we want to consider. Then there's a new object or we want to classify, decide is cheating or not. And we have a target attribute Y. Okay, so the 3 steps of the algorithm. First, we read the database D to calculate the distance between X and all the records in the database D. Then we find Z, the set of the K nearest neighbor of X, like K equal 3, okay, the top 3 most similar, for example. Then we do the vote. We take the majority, we return the most frequent value for the target attribute in the set of the nearest neighbors. Okay, so this is very simple, right? So if you want to do programming, it's really easy for the KNN algorithm. Now I would like to make some observations about this. Okay, how do we choose the K in practice to get the good results? So let's take some example. Here we have the 2-dimensional data with 2 dimensions, X and Y. Okay, and we have some data points, some objects of 2 different classes, the minus and the plus. Okay, now we have a new object X. We want to decide X belongs to which class, the minus or the plus. So how do we do this? Let's say X is what we want to classify. Let's say we choose K equal 1. So K equal 1 means you look at the closest object that is the closest to X. Okay, so it is a minus, so then our prediction is that X is also a minus, the class minus. Now, what about if we choose K equal 2? If we choose K equal 2, then the 2 closest points beside X, they are minus and plus. So if we do the vote, we take the majority, we don't know which one to choose because there's 1 plus, 1 minus. So we can choose randomly minus or plus. This would be the prediction. Now, if we choose k equal 3, we take the 3 nearest neighbors closer of x, okay, the points that are the closest to x. So we have 2 plus and 1 minus. So now the prediction will be plus. So what I want to show you here is simple. Depending how you choose k, you can get different result. Here the prediction is minus, here minus or plus, or here plus. Okay. So how to choose k influence the result. The classification will be good or not. So you can make some observation. If k is too small, maybe the results are not reliable, because if there's some noise in your data, it will influence the result. The result will not be reliable. For example, if you choose k equal 1, then you take the decision, you do the prediction based on only one other point. Okay, it is not reliable. You should choose some value of k that is big enough. But if k is too large, maybe you will consider some neighbors that are not from the same class. Okay, so let me show you an illustration here. Here we choose k, for example, more than 7. Okay, k like 15 or 20 maybe. So if you will choose k equal 5, you will look only the points around x. Okay, but if you choose too big, you will also include a lot of minus in this, and then the prediction will be minus. It will be wrong. Okay, because of the data. So we need to be careful. We can choose k too small, is not reliable. Too big, maybe we include the points from the other classes. And if we choose k really too big, it will also maybe give the result are not very good. Okay, or we need to have a lot of data to have the bigger values of k. So how to choose k? There is one way we can do to make this easier. We calculate the accuracy or error when we do the prediction with k equal 1. Then we repeat the experiment many times with larger values of k, like k equal 2, 3, 4, 5, 6, 7, and so on. And then we choose the value of k that will give the best accuracy or the lower error. Okay. So in general, if we have more data, then we can choose the larger value of k. Okay. So now, one aspect I did not explain yet is how to measure the distance between 2 points in KNN. So if the data is only numerical, then you could measure the distance between 2 objects A and B using the Euclidean distance, for example. So this is the formula. It is simply the distance between 2 points. I think all of you know how to calculate this. Okay, it is easy. So here still I give some example in case you don't remember. Okay, let's say we have 2 points. B has a 4 dimension, 0, 3, 4, 5, the values, and A 7, 6, 3, minus 1. So here you have the calculation, how to calculate the distance between the 2 points. The distance is 9.7. Okay, so this should be easy, right? So let's continue. But there's a problem about this, okay? In the real data, all the attributes may not have the same range of values. For example, here I have some data about some customers, maybe, okay? I have the age. You know the age usually is between, let's say, 0 to 120, okay? And we have another variable attribute, the income. the range of value for the income is much bigger. It is maybe 0 to 100,000, or it could be more. Okay, so here I use 100,000 in my example. So if we calculate the distance with these two attributes, it will not be fair, because the income will be more important than the age in the calculation. Okay, because the value for incomes, the values, are much bigger than the age in general. So how to solve this problem? One way to do is to do the normalization. We can use, for example, the min-max normalization. So that means all the values we have, the numbers, we will change them to the values between 0 and 1. So how to do? Normalization of a value for some attribute will be the value minus the minimum for this attribute divided by the maximum for this attribute minus the minimum. So let me show you. It is very simple. Okay. So here, let's say we take the age of John. So it will be 99 minus the minimum 0 divided by the maximum 120 minus 0. Okay, so let's see what's the result. The result would be 0.99. And here you have the same for the income. You can do the calculation. It will give you this result. Okay. Okay, so now all the attributes, the number, the numerical values are between 0 and 1. So maybe it will be more fair when we calculate the distance. Now there is another problem also when we do KNN. Let's say I have the data like this. Here some attributes are not relevant. For example, the customer ID. Okay, I should not use this to calculate the distance, right? And maybe the gender is not relevant for what I want to do. It depends, okay. So, or the education. So here, for example, I remove the customer ID and I will remove the education because I think they are not relevant. So this is something important to do, okay, also. Think about which attributes are important or not important in your data. Now, another question that is important to talk about. What about the nominal attributes? That means the attributes that are not the numbers, like the name. It is a string, okay, some text, or the gender, male or female, or the education, like PhD or master. So how to deal with these attributes? So one simple way, for example, for the gender, is to give a number to each value. So male, the value is 1, and female, the value is 0. Okay, so that could work, okay, but there are some other problems. Let me explain. So in general, if we just use the Euclidean distance, it has some problem, especially if we do like I just explained, male and female, 0 and 1. Okay, so let me show you some example to illustrate some problem. So here, let's say I have the data about shopping. Okay, each vector here is the data of one customer, and the 1 or 0 means the people buy or did not buy a product. So here, 1 means the person buy the apple. 0 means don't buy the apple. 1 means buy the bread. Here means buy the bread. Buy the cake, buy the cake. Buy the eggs, and so on. Okay. So we have some data where each customer has many attributes that tell us what they buy. Now, let's say I have two customers like this, okay? They buy almost the same thing. They have all the 1s and 1 0, and 1 0 and all the 1s. So, what will be the Euclidean distance? It will be 1.4142. because they are very, very similar. Only 2, 0 is different. But if I have the data like on the right, okay, these two customers only buy two things and everything is different. They never buy the same thing. But if we use the Euclidean distance, then still it will say it has 1.41 the distance. It is the same, okay. So obviously this is not good, this behavior for the Euclidean distance. So we need to be careful when we use the numbers to represent the nominal values, like bi or not bi, or male or female, and so on. So to solve this problem, there are some other distance measures. So for the nominal attributes, what we can do more generally, okay, if we have two values a and b are identical, we can say the distance between them is 0. 0 means they are the same. And if two values a and b are different, we say the distance is 1. So this is one way to deal with the nominal attributes. There are also some alternatives. Let's say we have many values, like the color. It could be white, black, blue, red, green, and so on. So then we could assign different values from 0 to 1 to indicate, for example, that blue is more similar to white than to black, and so on. Light blue, okay. So it depends on the application. We can design the distance measure in different ways. So now, how to select the class when we want to make a prediction? A simple way is to do the majority vote. So choose the most frequent class among the k nearest neighbor as the prediction. And if there is a tie, there is the same number for all the class, the same number of values. Then we choose randomly, okay. So for example, here we have x. We choose k equal 4. There are 2 plus, 2 minus. This is a tie. So we choose plus or minus, as I explained before. So this is the basic way to do the prediction for KNN. But there is one problem also with this. The problem is all the k neighbors have the same influence on the prediction, but some of them are more far, okay? So if you look carefully at this picture, the 2 plus are closer to x than the minus. So this is not really fair. Actually, if you choose k equal 4, of course there are 2 plus, 2 minus, it is a tie, but the plus are closer. So maybe the prediction should be a plus instead, okay? So how to solve that problem? So the solution is to use another way to do the prediction. Do the weighted majority vote. So we have some instance we want to classify x. And then for all the neighbors, we calculate a weight that indicates the influence. So if the neighbor is closer, it will have a more important vote. And if it is more far, the vote will be less important. So if we have a neighbor A, the weight of A will be 1 divided by the distance from A to x, the square of this. So then each vote will be multiplied by the weight. And by doing this, the points that are closer, the neighbors that are closer, will be more important than the points that are more far. Another issue I would like to explain is, what if there are some values that are missing in the data? So here we don't have the age, we don't have the gender. How to deal with this? So there is a solution. If two values a and b are missing, the distance between a and b is 1. We assume that they are different. Okay, this is an assumption. And if we have two values a and b and only b is missing, the distance from A to B will be 1 minus A or 0 minus A. We take the maximum. So we don't know if B is 1 or 0. Okay, we suppose we only have two values here. So we take the maximum of this as a guess. Okay. So I explained KNN today. Okay. What are the advantages and disadvantages of KNN? First, we don't need to build a model, but it can be time consuming to classify a new object because we don't do the calculation before. If we want to do the prediction, we need to find the closest neighbor, and this will take some time. We need to scan the data and so on. And what is interesting about KNN, the predictions are always made based on the local information. If you want to do a prediction for a point, you will look at the points that are around. You will not use the points that are far, okay, to do the prediction. So this is interesting. But we need to choose K carefully to get the accurate result. We need to have enough data. And if there is some noise and K is too small, maybe the result is not very good. But KNN is very simple to do the programming. Okay, so it is very easy to use. And the result can be quite good. So it is a good approach to try first before you try something else. So if we don't pay attention also, the result might be influenced by the irrelevant attributes. So we need to remove them, the missing values, and also maybe the noise. So maybe we need to use the weight, as I explained. And also how to choose the distance measure, as the choice of the distance measure has a great influence on the result. So how fast is KNN? If we have many dimensions or we have a very large database, then calculating the distance to the neighbor will be very time consuming. So there are two optimizations we can use. First, we calculate the distance using only some of the attributes, not all of them. And then, when we calculate the distance, if the temporary result for a point is already greater than the K closest point until now, we stop calculating the distance. So this is some way to make it a little bit faster. Okay. Another optimization is to use some special data structure like the KD3. I will not explain today, but if you are interested, you can look this up. KD3, it is a special data structure, a kind of binary tree, and you can search for the K nearest neighbor very quickly, okay, without looking at all the data points. So if you use the right data structure, you can also make this much faster, okay. So that's all for today. I just wanted to explain the KNN algorithm. I hope it has been interesting. Thank you for watching. Okay.